algebra. Don't know what a slide, but I do know what it was too. What could be with you? What a wonderful world this would be.
Welcome back, everybody, to Mr. K's 30 Minutes of Math. I hope you all had a great Memorial Day weekend. 3-day weekends are always very nice, and we had some nice weather in there too to be able to enjoy. Just one day that was kind of cloudy and cool, but the others were very nice. So hope you had a great weekend, and let's dive into our math today, beginning with our riddle from last Friday. So we shut the video off and we'll go right into our riddle. As you may recall, we were toasting some bread, and we had a toaster with 2 slots, and just like the picture there below. And the question was, how do you toast both sides of bread in 3 minutes when you know that it takes 1 minute to toast each side of the toast? All right, so here's how it goes. It's a little bit tricky, but there is a great solution. So here it is, ladies and gentlemen. So first, you put 2 pieces of bread into the toaster. All right. Then after 1 minute, one side of each of the 2 breads or pieces of bread gets toasted. All right. So after 1 minute, you have 2 pieces of bread with each of them have one side toasted. Okay, then you flip one piece, so you toast the other side, but here's the trick. You take the other one out of the toaster. Okay, then you place the 3rd piece of bread into the free space on the toaster. After the 2nd minute, you take the completely toasted bread out, so that was the first one, and flip the other one. Then place the half toasted bread into the free space to toast the fresh side. And then after 1 more minute, all 3 pieces of bread get toasted on both sides. So there you have it. I think that one is pretty clever. You can try it if you have a toaster at home, especially if you've got one that has 2 slots and it only toasts one side at a time. But this is a good one. Try it out on friends and family. All right, let's go ahead and dive into our homework from Friday night. We had a line y equals 1/6 x plus 1, and we're going to graph this one. So we know our y-intercept is plus 1. So it's going to cross the y-axis at plus 1. And we know our slope is 1/6, which means we're going to rise 1 and then run 6, and it's positive, so to the right. 1, 2, 3, 4, 5, 6. And then let's get our handy ruler out to connect those 2. And there you go. That is what that line looks like. Well done, folks. All right, let's dive into today's work. We have our friends on the chat have returned with some slightly different numbers and a slightly different question. Be careful, note that this one is not saying how much altogether, but how much longer does she run on Monday and Tuesday? So Monday and Tuesday together as compared to Wednesday. Go ahead, take a second and work on that one, and we will be right back. Okay, welcome back, and I see some wonderful answers coming in, and I'm very excited to see that Delilah wrote in. So did Ezra, a couple others. Fantastic. All right, let's see. So Delilah ran 4/10 of a mile on Monday, 1.3 miles on Tuesday, and 63 hundredths of a mile on Wednesday. How much longer did she run on Monday and Tuesday as compared to Wednesday? So we have fractions and decimals. We can convert them all into decimals, or we could convert them all into fractions. I'm going to go with fractions this time around. So we have 4/10 on Monday, and then we have 1 3/10, which is the same as this, on Tuesday. So Monday and Tuesday together, 4/10 plus 1 3/10 should give you 1 7/10. And then on Wednesday, we have 63 hundredths. And so we want to know how much more on Monday and Tuesday. So how much more is 1 7/10 than 63 hundredths? Well, if we turn that 1 7/10 to 1 70 hundredths, which is exactly the same thing, and we subtract 63 hundredths, which is the amount for Wednesday, we're left with 1 7 hundredths, or as some of you wrote in, that's exactly the same as 1.07. Well done indeed. All right, let's go ahead and see what we have next, this time with Donna. And again, we're asking how much further did she swim on Monday and Tuesday as compared to Wednesday? Okay, let's take a look at this one again. We can do it with decimals or fractions, same exact thing. I'm going to do decimals this time. So on Monday, Donna swam 4/10 of a mile, 0.4. On Tuesday, 2/10 of a mile, which we know is exactly the same as 0.2. And on Wednesday, 29 hundredths of a mile, which we know is exactly the same as 0.29. And so again, how much further did she swim on Monday and Tuesday? Monday and Tuesday. So together, 4/10 and 2/10 is going to give us 6/10 as compared to Wednesday. So 6/10 versus 29 hundredths. We know that 6/10 is exactly the same as 60 hundredths. 60 hundredths minus 29 hundredths gives us 0 ones and 31 hundredths. There you have it, which we know can also be written as 31 hundredths, which some of you did. So well done indeed, well done indeed. Fantastic to Donna, Delilah, Ezra, fantastic work. Very, very impressive. All right, Ezra is up, and pay attention. How much longer did he play on Tuesday and Wednesday as compared to Monday on this one? Go ahead and try that. Okay, I realize the slide is not showing a number of you have written in. Hold on one second. Let me see if I can fix that. Let me stop the share and then do a new share. Hold on one second. I think the internet's been acting up a little bit crazy, so hold on one second. All right, here we go. Share to the iPad. Let's see if it comes back. All right, how is that, friends? Is that coming back now? Go ahead and let me know, and that would be fantastic. I think it should be good now. All right, yes, good. All right, thank you. Okay, there it is. And again, how much longer did he play on Tuesday and Wednesday as compared to Monday? Now go ahead and work on it. Okay, let's bring this one back. 4/10 of an hour on Monday, 0.7 or 7/10 on Tuesday, and 32 hundredths of an hour on Wednesday. How much longer did he play on Tuesday and Wednesday? So we're going to put those together as compared to Monday. Let's do fractions this time. 7/10 is exactly the same as 7/10, 0.7, 7/10, which is the same as 70 hundredths. All just different ways of saying the exact same thing. So if I put these together on Tuesday and Wednesday, that would be 102 hundredths. And using our number bonds, we know 100 hundredths is 1, 1. And then we have 2 hundredths left over. All right, that's how much we had for Tuesday and Wednesday. And then on Monday, 4/10, which we know is the same as 40 hundredths. All right, so I have 1, 1, and 2 hundredths, and I'm going to subtract 40 hundredths. Well, if I subtract 40 hundredths from 1 and 2 hundredths, I'm going to actually, it's going to be helpful to go back to our 102 hundredths. And that would leave us with this. 102 hundredths minus 40 hundredths equals 62 hundredths of an hour, which is the same thing we know as 0 0.62. So there you have it. Well done indeed. All right. And last, but certainly not least, we have Henry and his soccer. Go ahead and check this one, and we'll be right back. Okay, and our last one before our joke. We have 38 hundredths on Monday, 5 tenths on Tuesday, and 2 tenths on Wednesday. And we want to know how much longer did he play on Tuesday and Wednesday as compared to Monday. So we're going to add up Tuesday and Wednesday. We have 5 tenths and 2 tenths. And we know that together, if I add those up, I'm going to get 7 tenths, or we could do it 0.7, exact same thing. Okay, and then we want to compare that with Monday, which was 38 hundredths. We know 7 tenths is exactly the same as 70 hundredths. I can do it in decimals, I can do it in fractions. All of these things are exactly the same. So if I have 70 hundredths right there, and I subtract 38 hundredths, which is right there, we are left with 32 hundredths. And there you go. That is your answer, which is also the same as 0.32. Sorry, my numbers are all over the place, but I was running out of room. All right, there you go. Well done indeed. Well done indeed. Here is our joke of the day. And this one is in favor, or in honor, rather, of all the insects out there buzzing around because of the beautiful flowers. What did the bee say when it solved the math problem? Okay, let's see. We have one answer as bzz and one, Delilah writes in, I did it, honey, which I think is pretty clever. Well done. All right, well, here is the answer that I had. I've got it. I like that one. I'm giving it a like. All right, I appreciate your positive reinforcement on that joke. Thank you very much. All right, let's go to our advanced time. I'm giving you 3 coordinates, 0, 3, and 1, 4. And I want you to figure out what is the equation for the line that connects those 2 points. All right, go ahead and give that one a try. Be right back. Okay, let's take a look at this one. 0, 3. Where is 0, 3? Remember, we always do our x coordinate first. 0, 3. So we're going nowhere on the x-axis, and then we're going positive 3 on the y-axis. Okay, positive 3. 1, 2, 3. So there we are. That is our first coordinate. And let's do our second coordinate. 1, 4. So 1 on the x, and then positive 4. 1, 2, 3, 4. 4 on the y. All right. Now I'm going to bring out our friend the ruler, connect that, and here we go. All right. That's what the line looks like, and our equation would be y equals m, remember, is our slope. What's our slope? Well, we're going up 1 and over 1. So you could do 1 over 1, rise over run, which is the same thing as just 1, x. And where is our y-intercept? Where does it cross the y-axis? It crosses right there at 3. So there is your equation. Y equals 1x, or you could just say x, because 1x is x. 1x plus 3. Well done, guys. Well done indeed. Okay, go ahead and try this one. Okay, that's a good place to pause in our music. All right, let's take a look at what we got. 0, 0. Well, that's right here. And 5, 1 would be right here, right? 5 on the X, 1 on the Y. Let's bring out our trusty friend, the ruler. And let's look at what our line looks like. Okay. And remember, we always have the arrows on the ends of our lines because the line goes on forever. Okay, let's do our equation. Y equals, what is our slope? Well, we're rising 1, and then we're running 1, 2, 3, 4, 5. So 1/5 x plus, and what is our y-intercept? Where do we cross the y-axis? Well, we cross it right at 0. So y equals 1/5 x plus 0, which is the same, by the way, as just y equals 1/5 x. Good job, friends. Good job indeed. All right, let's try this one. All right, let's take a look at this one. We're going to start with -2, 0. So -2, 0 is right there. And then 0, 1 is right there. We get our friend the ruler back. So our line looks like this. Okay, let's do our equation. Y equals, what is our slope? Well, we're going up 1 and we're going to the right 2. So positive 1/2. So y equals 1/2 x plus, where do we cross the y-axis? We cross it right at 1. Y equals 1/2 x plus 1. Well done, guys. Well done indeed. I know it's a little bit tricky and sometimes we get our x and our y mixed up. That's no problem. You guys are doing, this is 7th grade work. So super proud of what you are doing. All right, we're just about out of time. So here is tonight's homework. Go ahead, take a screenshot or take a picture with a phone or write it down. You want to find the equation for a line that has these 2 points, 2, 0, and 0, 1. 2, 0, and 0, 1. Okay, and last, here is our riddle for the day. We're doing a little bit of laundry today for our riddle. There are 6 black socks, 8 brown socks, 4 blue socks, and 2 red socks in a sock drawer. Can you figure out the minimum number of socks to be pulled out in order to get a matching pair for sure. And I want you to pretend your eyes are closed, because obviously if your eyes were open, you could just pull out 2 matching socks. So pretend that your eyes are closed and you pulled out 2 socks. I'm sorry, you pulled out how many socks would you need to pull out to make sure that you got a matching pair? All right, we'll talk about that one tomorrow. Have a great afternoon. Bye, everybody.